So how small can you go with some tooling? And again, the tooling, everything that you see here and on subsequent slides, it requires a tool to make the molded part, so you have to kind of think backwards with respect to if you want to make a blind hole, for example, you're going to make a core to make that blind hole. So you kind of have to think, what does the tool need to look like to make the part? So in these cases, however, you can see next to the penny here that that's a machined part. And we have end mills, believe it or not, it makes me actually smile every time I say this because it's ridiculous. End mills as small as 1/10 of a thousandth of an inch, or 3 micron. And the smallest double fluted end mill, which is still a very small diameter but has a helix at the end that's double fluted, and that is 4/10 end mill that's double fluted. So it's literally very challenging to see, even with the naked eye, to machine some of these parts with these very tiny end mills. Yes, we do break those end mills, and just like any process, you're going to develop the process to not break that end mill over time with certain materials. So it's a certain recipe, and once we got to 1/1000th of an inch and we're comfortable with certain materials, whether it be stainless or polymer, we keep pushing the envelope to 8/10, to 7/10, to 4/10, to now 1/10. So in the past 3 or 4 years, we were able to develop the methods to machine extremely small features. The ejector pins, which actually is taking, again, a polymer to eject off of the mold itself, those can be as small as a hair size. And they are a moving part. They're every 10 seconds they're coming out and pushing a part out. So they do tend to wear that particular size. We've been able to make those last for 3.5 years before they break. Again, getting back to that, maintaining that tool very properly to be able to allow that to happen. Cavities as small as 7/1000ths of an inch, and I do have some parts that I can show on this a couple of slides to show you how small those are. Core pins a little bit less than 3/1000ths of an inch, or about a hair sized. Gates, which is where the polymer would enter the mold, is 2/1000ths of an inch, or 50 microns. Again, wall thickness is down to 1.5 thousandths, slots and channels to literally a half a micron, or 20 millionths. Not a foot, that's an inch. Here are some micro-machined examples, and this particular material is PEEK, polyether ether ketone, a very popular material for micro-machining and a very popular material for implant use. It's a very strong material, which is why it's used in micro-machining a lot, and it's biocompatible. So the part that you see here on the finger to the left, I have a better picture of, but just to give you an idea of how small they are, I can see this. And then also, if you look right near the date on the dime, you will see the true size of the machined part. Remember, this is actually micro-machined out of PEEK. And the insides of that, you can actually see in the lower right-hand photo that the radii inside is less than a half a thousandth, or right around a half a thousandth of an inch. So we had to use a 1/1000th end mill to create that half-thousandth radius. So literally 1/4 of a hair-sized end mill to achieve these parts. All these three go together to create that actual wedge-shaped part is put with another wedge-shaped part, and there's a suture that threads through that small hole, and this is used for gastric bypass surgery. Some other micro-machining components here. On the right-hand side, this is a broach used for like an EDM type process, but a forming process. Upper left-hand side is a catheter tip. And down below you can see the very small features, about the size, a little bit less than the size of the date on a penny, and that is a cavity for a electrical connector. This is a very small, there's no scale here, so I apologize, but the slots here in the back side of this part are 3/1000ths of an inch, or 75 micron, and this is a machined part used for a surgical instrument. Here are some other parts. Some of these are metal injection molded, and some are stamped, and again, some are machined. But all require, even if you have a stamping or a metal injection molding or a thermoplastic injection molding, all require the machining of a mold to be able to make this geometry. So, and that is truly the enabler to any of these parts. The tool has to be pristine, the tool has to be extremely small and extremely strong and robust to last for a very long time, to make literally millions of these parts. So the tooling and the micro machining is the true enabler to a lot of these components that you're seeing here and throughout this presentation.